In this video, we're going to continue with some more expected value problems. In example 1 here, we see that an American roulette wheel typically has 38 equally spaced numbers with the numbered slots with the numbers 0, 00, and 1 through 36. A player bets $1 that an odd number comes up, wins $1 and gets the original $1 bet back. The 0 and 00 are considered to be neither even nor odd for the purposes of roulette. What's the expected value of this game to a player of the game? Alright, so again, in this kind of game, we have a winner and a loser. I'm sorry, you can win or you can lose. It's not entirely different than what I said. If you win $1. If you lose $1. The probability of winning, well, of those 38 numbers, 1 through 36, half of 1 through 36, 18 of them are odd. 18 over 38. I can simplify it, doesn't really matter if I do. The losing numbers, probably that should be 10/19. So the expected value here would be 1 times 9/19 plus a -1 times 10/19, which is going to work out to be a negative 0.0526 or so. What this expected value means again is that each dollar I spend betting on this should cost me about 5 cents. If I play this repeatedly, I would expect to lose on average about 5 cents for each time that I play. So if I play long enough, I'm almost certain to lose money with this. I'll add, again, all casino games are going to have a negative expected value. Here in example 2, you're told volunteers working on to raise funds for a new community library sold 1,000 raffle tickets at $10 each. Tickets are to be randomly drawn and prizes are awarded as follows. 1 prize is $1,000, there's 20 prizes of $50, and 100 prizes of $20. A asks us what's the expected value of this raffle to you if you buy just 1 ticket. So again, as we do with all of these expected value problems, we're going to make a probability distribution chart. Okay, so we need to know the appropriate numbers and the probabilities of those things. But if we look carefully at this, there's really 4 things that can happen. You can win the $1,000 prize, the $50 prize, the $20 prize, or not, or you can lose. So there's 4 things that can happen. I'm going to call this win big, win medium, win small, or what's that other thing? Oh yeah, lose. Okay. Now in terms of the appropriate numbers to put with those things, if you go out, you pay $10 for the raffle, and you don't get any of the prizes, that lose amount should be a -10. Now it's pretty easy. Looking at the mechanics of how a typical raffle works, again you go up and there's the Girl Scout or whoever, and they're sitting there taking your money, and you give them $10. And then sometime later they do a drawing out of the hat and they pull out the $1,000 winning ticket. And if you're the winner, you run up and you're shouting and you're screaming and you get $1,000 for that. But you don't get your $10 back. So when you want to think about how this works, the big prize, what it's really worth to you, what you won, I would call that $990 because you have $990 more than you started with. The medium prize in similar ways, it's not really 50, it should be 40, $10 less than the $50 prize. The $120 prizes are really worth $10 to you each. Okay, looking at the probabilities of these, there was 1 prize out of the 1,000 raffle tickets. That was the big prize. There were 20 out of the 1,000 medium prizes. There were 100 of the small prizes. And there was a reason I didn't simplify these. If I look at this now, there was 1 plus 20 plus 100, 121 total winning prizes. So the rest of them, the other 879 out of the 1,000, are the losing prizes. So our expected value, in the familiar way we've been doing this, it's 990 times 1 1,000 plus 40 times 20 1,000s plus 10 times 100 1,000s plus a -10 times 879 thousandths will give us our expected value, which is a -6. What that means is, on average, for each ticket we buy, we should expect to lose $6. For part B, we're asked what would happen if we buy all the tickets. Well, if I buy all the tickets, that means I win all the prizes. So I win the $1,000 prize. There's one of those. I win all 20 of the $50 prizes. I win all 100 of the $20 prizes. So I'm going to win $1,000. $1,000. $2,000. I'm going to win $4,000 in prizes. And I'm going to buy all the tickets. So I'm going to spend, let's see, $10 times 1,000 tickets, $10,000. So I'm out $6,000. That is, a negative $6,000 is the result to me if I buy all the tickets. In fact, I could just write the Girl Scouts or whoever a check for $6,000 and just be done with it, because that's exactly what would happen if I bought all the tickets. So again, the end result, if I buy all of them, is a negative $6,000. Well, there were 1,000 tickets. So on average, we see that expected value number coming back. On average, for each of these tickets, I actually expect to lose $6. That's taking into account this entire situation. Now, this is actually a different sort of problem than all the rest, because this is a closed system. We can actually look at what happens if you do everything in this problem, which was not the case in anything else that we looked at, but that's the same basic idea here. We want to examine with the expected value. Reading through example 3 again, we're asked to find these expected returns. For site A, well, we've got some numbers, we've got some probabilities. This should hopefully look familiar. For site A, it's estimated that they'll net $20 million if it's successful, with a 0.3 probability, and they'll lose $3 million if it's not successful, for 0.7 probability. Again, even if they didn't tell me that, 1 minus 0.3 is 0.7. So the expected value for A is 20 times 0.3 plus negative 3 times 0.7. Expected return, expected value, really we're going to mean the same thing with this, so this should be 3.9. And if my board was dry, that would have actually erased on there. Dry erase markers don't work on a wet erased board. All right, that should be 3.9. For B, here the appropriate numbers for B are 60 million if it's successful with a probability of 0.21, and 5 million if it's not successful with a probability of 0.79. Working this out, I'll grab my handy dandy little calculator here. 60 times 0.21 plus a negative 5 times 0.79. I'm going to get this as 8.65. On the basis of the expected return only, I'm going to pick site B. Now, let's look at this a little more carefully. If I asked you the question, which is more likely to yield a success? A is. Substantially so, actually. Almost 50% is higher likely return of getting a positive return for A. And in fact, looking at B, it also has a higher likelihood that not only is it more likely that you'll go down, but it's more likely that you'll go down by more. Right, so this is kind of like, this is the big gusher exploration site, and this is less of a return, but less of a risk. So if you were the CEOs of the companies, you might choose differently, but based on the expected return, B is the better option. And if you think about what most sorts of companies of this sort do, they're going to have repeated options of doing these sorts of projects over and over and over. And if that is the case, this is certainly a good idea. If it's not, you may want to weigh other considerations. But the question here was, which site should the company choose according to the expected return? Well, the higher expected return is the one they should choose based on that. In example 4, we're told an investment club is considering purchasing a stock. Their research suggests that there's a 40% chance of making $13,000, a 20% chance of breaking even, and a 40% chance of losing $6,400. Let's find the expectation of this purchase. Expectation is another word for expected value. In this problem, we can win, break even, or lose. I think that's a good indication, or review of what they have there. If they make money, they're going to make $13,000 with a 0.4 probability. Breaking even means they make zero. And losing $6,400 is losing $6,400. The expected value here, or the expectation, would be 13,000 times 0.4 plus 0 times 0.2, which you really don't have to put your calculator, plus a negative 6,400 times 0.4. Working that out. I get 2640. So another way that these sorts of problems can be worded. Example 5 here deals with life insurance. Here we're told the main which is to purchase a 5-year term life insurance policy that will pay the beneficiary $25,000 in the event that the man's death occurs in the next 5 years. Using life insurance tables, he determines that the probability he'll live for another 5 years is 0.96. What's the minimum amount he can expect to pay for his premium? Alright, so what we're going to work on the assumption of is that the minimum amount deals with an expected value of 0. So we want to find that amount. The premium, well, in this example, a couple things can happen. A person can live, or we'll just say not, right? Those are the two things that can happen. And the probabilities are given to us in the problem. One of the probability of him living is 0.96. So the probability of him not living is 0.04. 1 minus the probability of living will give you the probability of not living. Alright. Well, if the person lives, what the transaction will involve is the premium. So let's think about this from the insurance company's point of view. And you always want to think about it with one person's point of view in mind, or one side of the discussion perspective in mind. And I'll tell you, if the expected value is 0, that's the same expected value for both sides, the insurance company, or it's hard to pin this down, but we'll say the beneficiary, because they're the person who will be getting the amount at the end here. But let's deal with the insurance company's point of view. If the person lives, the insurance company gets the premium. We don't know what that is. Let's call it X. Alright, if the person does not live, what's going to go on here is that the insurance company is going to send that person's beneficiary a check for $25,000. But, and this is where the problem gets a little more tricky because you have to pay attention to this, but the insurance company is going to keep the premium. So it's not just going to be a negative $25,000. Alright. What this financial transaction will really be for the insurance company, well, excuse me, since they keep the premium, let's say the premium was $200, this would be like a negative $24,800. So I need to subtract off that premium from the $25,000. And this is one of the right ways to do it. You may want to play around with some numbers here and verify that this is the case. But this is what this would look like to the insurance company. So the expected value here would be 0.96x plus a negative 25,000 minus x times 0.04. Working this out, we're going to get 0.96x minus 25,000 times 0.04 should be 1,000 plus 0.04x equals 0. Adding up that 0.96x plus 0.04x conveniently works out to be x. Adding the 1,000 both sides conveniently works out to be 1,000. So we're going to see the minimum amount the person could expect to pay would be $1,000 here. And that's the last of the examples I'll do on expected value. You've seen a wide range of problems that can deal with expected value in different ways we can ask that question. You need to be familiar with all of these. You'll see several of these again on your homework and as part of your Wiki assignment.